This year, at the Spring Festival Gala, a group of steel warriors took over everyone's screen once again. I'm talking about Unitree Robotics humanoid robots. They weren't there to dance traditional folk routines. They were throwing drunken boxing combos, spinning nunchucks, wielding staffs and swords, and even landing consecutive backflips. From last year's Yangbot to this year's Woobot, in just 1 year, China's humanoid robots have completed a stunning technological leap. Today, let's break down the hardcore engineering behind those jaw-dropping moves and see how Chinese robotics evolved from canned dance to real kung fu. Let's start with formation control. Last year, 16 robots changed formations by walking slowly across the stage, almost like a casual stroll in the park. This year, more than 20 robots were sprinting and weaving through each other at speeds up to 4 meters per second, close to a 100-meter dash pace. What made that possible? Fully autonomous swarm control. Each robot is equipped with 3D LiDAR, scanning the entire stage in real time like a bat. They process environmental data hundreds of times per second. There's no backstage operator directing traffic. Every robot knows where it is and where it needs to go. Even more impressive, if one robot drifts off its path, it can autonomously recover without human intervention. Wang Xingxing, founder of Unitree Robotics, put it perfectly in a CCTV interview. Last year was executing preset programs. This year is adapting autonomously to the environment. That single sentence captures the essence of the leap from automation to intelligence. Now let's talk about the most thrilling part, the aerial stunts. This year, the robots achieved multiple world-first breakthroughs, continuous parkour flips over tables, launched backflips exceeding 3 meters in height, consecutive one-leg flips, wall-assisted backflips after 2 steps, and even a 7.5 rotation air flare. What makes this so difficult? Centimeter-level landing precision. Imagine a steel body weighing dozens of kilograms, rotating 360 or even 720 degrees in the air, then landing exactly on a designated spot with only a few centimeters of allowable error. Any deviation, and it crashes. How did Unitree pull this off? A 3-part technical combination. First, reinforcement learning. In simulation, the robots fell thousands upon thousands of times, learning the optimal posture and control strategies. Second, AI-based sensor fusion and localization. By combining onboard proprioception with LiDAR data, they solved the problem of localization drift during high-speed motion. Third, major hardware upgrades. Higher power density joint motors, optimized limb structures, and new shock-absorbing components, essentially giving the robot super knees and steel ankles. One of the most impressive feats was the consecutive single-leg backflip. During single-leg support, the robot must maintain absolute stability. Any slight vibration leads to failure. Last year, you could still see compensatory arm swings. This year, they're almost gone. That tells you the dynamic balance control has reached a new level of engineering maturity. And then there's weapon interaction. This year, robots wielded long staffs, nunchucks, and swords, even performing a sequence of drunken boxing. This touches one of the hardest problems in robotics, dexterous manipulation. Human martial artists rely on feel. Robots don't have nerves, so how do they manage it? The answer is physics modeling combined with reinforcement learning. The Unitree team built precise physical models for each weapon and trained the robots extensively in simulation. The robots learned dynamic perception and torque control. They can sense the state of the weapon in real time, adjust grip strength, and respond to external disturbances. To support this, Unitree developed a new generation of dexterous hands capable of quick weapon swapping and stable grasping. The leap from empty hand dancing to weapon mastery represents a huge breakthrough in fine manipulation capability. At this point, you might ask, beyond performing on stage, what can these robots actually do? That's the real question. According to Unitree, the technical challenges solved for the Gala are highly aligned with real-world applications. Swarm control translates directly to collaborative factory operations. Centimeter-level positioning supports warehouse logistics. Dexterous manipulation is essential for precision manufacturing and home service. And the market response has been immediate. According to JD.com, within just 2 hours of the Gala broadcast, robot search volume surged by 300%, orders increased by 150%, and high-end models priced at 630,000 RMB sold out within minutes. More importantly, the entire supply chain is maturing from reducers and motors to LiDAR systems, from algorithm frameworks to simulation platforms. China's robotics industry is shifting from concept-driven development to engineering and commercially driven growth. As some foreign media have put it, Chinese robotics is already next level. From handkerchief spinning to drunken boxing, from walking slowly to sprinting and flipping, Chinese robots have achieved in 1 year what might take others 5. This is not just a victory of technology, it's a victory of system-level engineering algorithms, hardware, sensing, and control, all working together. When these steel warriors step off the Gala stage and into factories, warehouses, and homes, what we're witnessing is not just a performance, it's the opening chapter of an intelligent era. As Wang Xingxing said, humanoid robots may have their ChatGPT moment within 1 or 2 years, and this year's Spring Festival Gala may well have been the prelude. Thanks for watching. I'll see you in the next episode.